Hi, my name is Lee Gitsis, Technology Services Manager for Com Solutions Company. Today we're going to discuss part two of our BYOD 2.0 series, Why the VDI Experiment Has Failed, the Evolution of VDI. As we discussed in part one, we found that VDI had a lot of promise, especially when enabling mobile technology such as iPads and iPhones and Android devices. It enables us to be able to deliver Windows-based enterprise applications to our end users. But what we've come to find is that it's very inefficient, expensive, low ROI, complicated, and a lot of the efficiencies we thought we could gain, we haven't been able to. And the reason for that, or the way we've found that we can fix that problem, is that we've realized that focusing on the desktop isn't really where we should be. VDI is not only about delivering desktops. VDI is actually about delivering applications and user experience. The desktop's just a method. At the end of the day, when I log into work and I log into my computer or my iPad or my iPhone, what I really want to do is access an application, not just access my desktop. I want to be able to get to my data. I want to be able to make content, edit content, read content, view content. And I use applications to do this. And I also expect to have a good user experience. When I watch a video, I expect it to not be choppy. I expect my desktop not to crash and bring down those documents that I'm in the middle of writing. So we found that the VDI is defined by more than just the desktop. It's also defined by application delivery and user experience. And in most cases, the application delivery and user experience are more important than the desktop itself. So all of the components that make up this solution have now evolved. The first is the way we deliver desktops. Virtual desktops are a one-to-one virtual desktop model, which is the way we've always known VDI. As we discussed, it's become a complicated and expensive way to deliver virtual desktops. When one user needs one virtual processor and 2 gigs of RAM, and I can usually fit on average 5 or 6 users on a core, we can quickly see how, when we're talking about thousands of users, how that can escalate into hardware requirements that are pretty tremendous. And we're moving them away from commodity-based endpoints into enterprise-class hardware. It's also, in some ways, useful. It's an isolated computing resource, so it's great for power users that are going to spike the processor and consume a lot of RAM. Won't affect other users. It's great for special use case users like executives or application developers that need to reboot the desktop or install applications. Um, but again, on the negative, it requires a significant infrastructure investment. A lot of the promise with it is still there. It's centralized. It's easy to deliver and provision. It uses a service-based IT model. It's secure. We're still presenting the desktop. We're still keeping the data in the data center. And with single image management, it's still efficient for support and deployment. But what we found is shared virtual desktops or hosted shared desktops have become the preferred deployment model. And it's a many-to-one model, and we've used it in the past with Terminal Server and WinFrame and Presentation Server, and now today XenApp published desktops. The big difference between what we've always known as those types of desktops and today is really the back end. With Windows 2008 R2, we can now run it in a 64-bit model, so we're over the 4 gig of RAM limitation. It's more flexible, it's more efficient, and we can also skin it to look like Windows 7. So now we can give a user a Windows 7 user experience regardless of the type of desktop they're accessing. With the fact that it's a shared environment and we can get 30, 40, 50 users on a single virtual machine, we're going to reduce our infrastructure investment. It's going to require a much smaller hardware footprint. It's also going to require much less of a virtual machine footprint, so there's less to manage. The types of users that fit into this model are data entry users, administrative type users, users that are going to use Microsoft Office a lot, light to medium users. It has the same advantages as traditional virtual desktops. It's centralized, the management's easy, it uses the same access method, it has a service-based model, and today, the same single image provisioning technologies that can be used for desktops can be used for servers that deploy shared virtual desktops. So we can even get the same efficient deployment and support cycle advantages that we would have with desktops with these technologies as well. And the other thing we found is that it satisfies 70 to 90% of users in most environments. So we can deploy shared virtual desktops to a vast majority of our users in most environments. The other aspect of this is application delivery. We've come to find that part of the failings of virtual desktops not only was just from the fact that we've got so many of them and they require so many resources, but when we install software on them, we quickly realized that we're not going to get one image for thousands of users because every time a user needs a different application, we need a different image. So we started to have image sprawl, and we started to end up with a lot of the same thing we had with fat clients, just back in the data center on more expensive hardware. So we realized we have to abstract the application from the desktop. Just like with server virtualization, the big advantage is we've abstracted the operating system from the actual hardware, and then we've abstracted the storage from the server resources to give us fault tolerance, highly available, flexible environment. With desktops, we want to accomplish the same thing, but what we've realized is we can't stop at the operating system. The user, as well as the application, have to be abstracted to get the most efficiency. So there's various ways of doing this. Of course, local installed applications, albeit they have issues, there are some still use cases where it's important. One of which is that it's easy. So if we've got small applications like Adobe Reader, like Silverlight, Java, things of that nature, they typically get installed still on the desktop operating system directly. All of our users are going to use them. It's not going to create an image issue. Application virtualization has really come to the forefront over the past few years. What this enables us to do is install the application into a package. So on a system that's running a like operating system as the one we're going to actually run the application on, we record the installation of the software. It then puts it into its own sandbox, which has a registry, INI files, system files, and all the things it needs to operate. Then we can take that package and we put it onto a file share and we give users access to it. And when they have access to it, a shortcut will appear on their desktop, they launch the shortcut, and the application is streamed directly down to the desktop. In a virtual desktop world, this is great. It enables us to abstract the application, and it gives us one single point to manage it. So that package that's going to 10,000 users, I only have to upgrade that one package to get the upgrade out to everybody. Furthermore, I can push it out beyond the desktop. I can push it out to I can push it out to end users straight to their endpoints, provided that their endpoints are Windows. So now, if I have endpoints that can handle the overhead of running my applications, rather than using my data center processing resources, I can actually stream that application straight down to the endpoint and take advantage of the local resources. So with those advantages in mind, application virtualizations become extremely popular. However, there are some limiting factors that have made it not the number one. With application virtualization, it can be extremely challenging to package the application. Oftentimes, applications cannot be virtualized. If they have services or drivers or legacy applications, oftentimes they just simply can't be virtualized. Other limiting factors are that oftentimes we need multiple solutions to virtualize all of our applications, so we end up having to run more than one solution. One of the nice things about Citrix is that it enables us to be able to support AppV as well as Citrix streaming. So if we do need to use both of those solutions, we can run them through the same management console. Additionally, if we want to just push applications out to endpoints, they have to be Windows endpoints or it won't be compatible. So for users that are using Macs or iPads or other devices, sending applications straight to them via streaming is not a possibility. So the next method, and what has become and pretty much always has been the most preferred method, is publishing an application. And really what that is using the same technology that we use to present a desktop to a user to present an application to a user. The only difference is instead of getting the entire desktop, the user gets the application painted on the screen and it looks and feels as if it's locally installed. This is very efficient. It allows us to use our backend resources and our data center resources, so the endpoint's power and operating system truly doesn't matter. When a user connects, it looks and feels like it's local, so users that are, say, Mac users, who are likely not Mac users because they love Windows, do not have to live in a Windows world. They can use this application, and it'll, via the client, will look and feel like it runs natively on their Mac. Even the graphical effects that happen when you dock an application will be exactly the same as they are as if you were using your native Mac application. Some of the disadvantages are not all applications can be published. So not all applications can work in a shared environment, and therefore we've run into a limitation there. Thank you very much.